Hi students, now I am going to teach a topic of moving iron instrument as voltmeter. Let's start the topic moving iron instrument as voltmeter. So this is our meter current. This is moving iron meter. So this is RM, so meter resistance, meter inductance, RSC, C is capacitor, and all this belongs to Zm. To increase voltmeter range, to increase voltmeter range, to increase voltmeter range, high value of non-inductive, high value of non-inductive resistance is connected, high value of non-inductive resistance is connected in series with voltmeter, in series with voltmeter. So to increase voltmeter range, high value of non-inductive resistance is connected in series with the voltmeter. So this is what your high, this is what your high value of non-inductive resistance is connected in series with the voltmeter. So let's calculate Zm. Zm is equal to Rm plus J omega Lm plus RSC parallel 1 by J omega C. So this gives rise to Rm plus J omega Lm plus RSC by 1 plus J omega RSC into 1 minus J omega RSC into C by 1 minus J omega RSC into C. So gives rise to Rm plus J omega Lm plus RSC minus J omega RSC square C by 1 plus omega square RSC square C. So this gives rise to Zm is equal to Rm plus J omega Lm plus RSC minus J omega RSC square C. So this gives rise to Rm plus RSC plus J omega Lm minus RSC square C for frequency independent, imaginary part equal to 0. So Lm minus RSC square C equal to 0. implies Lm is equal to Rs square C. C is equal to Lm by Rs square. So what this is approximate formula. This is approximate formula. And C is equal to 0.41 Lm by Rs square. So this is exact formula. This is exact formula. Then next step. So C is equal to 0.41 Lm by Rs square. This is independent of frequency, independent of frequency, and can be used for any frequency variation, and can be used for any frequency variation. The next, in case of moving iron voltmeter, in case of moving iron voltmeter, in case of moving iron voltmeter, we have to connect capacitor. We have to connect a capacitor across RSC in such a way that the capacitor reactance is cancelled out by inductive reactance of the basic meter then the meter is independent of frequency. Then the meter is independent of frequency. The next, now let's calibrate it for dependence of frequency. This is our meter current, moving iron, Rm, Lm, Rc, capacitor. So Z equivalent is what is this of a entire thing is Z equivalent. Z equivalent is equal to Rm plus Rsc plus j omega Lm plus 1 by j omega c. So this gives rise to Rm plus Rsc plus j omega Lm minus 1 by omega c. to make meter reading, to make voltmeter reading, to make voltmeter reading independent of frequency, variation, frequency of independence variation, omega Lm minus 1 by omega c is equal to 0. Omega Lm minus 1 by omega c equal to 1 by omega c. So c is equal to 1 by omega square Lm. The next, it depends on frequency. It depends on frequency, and it can be calibrated, and it can be calibrated, only for that particular frequency, but not for other frequencies. Then next, errors in MI instrument. Errors in MI instrument. Errors in MI instrument. One is of a frictional error. Second is of temperature error. Third is of a frequency error. Fourth is of a hysteresis error. Fifth is of a stray magnetic field error. Thanking you.